Hi, welcome. In today's video, we will try to learn how to write socket code to use UDP to send and receive messages. So we will be writing some server code which will be waiting for a client to send it some message using UDP, and the server will then send something back to the client so they can just chit chat for a while and then they'll both exit. We will be doing this in the C programming language, and when you look at the code, it might look a little bit tough to understand, but it's not. When you practice a lot and if you try to remember the different kinds of parameters they take, it should all become very easy for you. So let's get started. So I'm going to use the Windows subsystem for Linux as the underlying runtime, because the socket code that we will see will not work natively on Windows. So you should be using Cygwin, WSL, or some kind of a Linux distribution inside a hypervisor like VirtualBox or VMware. But I'll be using WSL and I'll be using VS Code for doing it. So go ahead and start VS Code. Okay. So now this VS Code instance is trying to connect to the WSL Ubuntu that is running in the background. Okay. And to be able to get here, you need a few extensions in VS Code. So take a look at this. Try to install all of these: remote development, remote WSL, remote SSH, and remote containers. You need to have these 4 extensions in your VS Code, and then also try to install the C extension from Microsoft. After you have these, please restart VS Code, and if you have WSL installed, at the bottom left here, you can click on that and then you can go to a new WSL window, and a new window of VS Code is going to open up, and then from there you can actually see the contents of your WSL Linux, not the Windows file structure, the Linux file structure. From there you can actually go and create a directory. For example, here in my home directory I have a CN lab directory. Inside that I've created a UDP directory. Inside that I have my client and server code. So let's check out the server code. So you have to include all of these header files for these programs to work. There is nothing to understand here, just that when you get some more practice, you will know that, oh, for using this function, I need that header file. But I'm kind of giving it to you directly here so that you can get a head start. As I've told you before in class, sockets have a port, because transport layer protocols like UDP and TCP, they need ports to work. So this server will probably get a message from the client, and it is going to listen for that message on a certain port. Okay, so we have defined that port to be 8080, and this number is less than 65536, because we know that ports are 16-bit numbers and they go all the way from 0 to 65535, and 8080 is within that range. We will see the significance of this max line thing a little later. So here is your main function. We have an integer called a sockfd, and this is what is going to store the socket, the ID of the socket that we are going to create. Then if you are sending a message, right, that message has to be inside a string, and that string is this hello. It's a pointer. Basically, strings are pointers in character pointers in C. And later, as you will see, we will try to receive something from the client, right? And whatever we receive from the client will be stored inside this buffer. This buffer needs to have a maximum size, and that maximum size is max line, which we have defined at the top here, and that's going to be 1024 characters. So buffer is going to store things coming from the client, as this is the server we're discussing here. And what the server is going to send is basically stored inside this string. So we have created two socket address structures. These structures, the serve address and the client address, they store the IP address and port for the socket, right? So when you are creating a socket, right, just creating the socket is not enough. You need to give the socket some identity. And that identity is going to be what? You create the socket by telling that I want a UDP socket or a TCP socket. That there goes the protocol. Then after that, we bind to the socket. The process is called as binding. And while you bind, you give the socket an identity. And you tell that, okay, this is going to be the IP address on which you're going to be listening. A computer can have many IP addresses, like the local host, the Wi-Fi interface can have its IP address, the Ethernet wired thing can have its IP address. So a computer is not constrained to have just one IP address. It can have many IP addresses. So you can tell, like, okay, socket, you bind yourself to all the IP addresses on the computer, or just this one, right? You can do that. And then, since you're going to use TCP or UDP, and these protocols need a port, we need to give the port also. So this IP and the port information, this information is going to be stored inside these structures, right? These structures store the IP and the port information necessary for binding a socket to an interface. Okay. So, and we will see more about this structure as we continue further. So what's going on in this line of code here? So we have called the socket function. It's going to create a new socket for us. And we have told it that give us an IPv4, the Internet Protocol version 4 socket. I mean, when we later give this socket an identity, we'll be giving you an IPv4 address, right? And it's going to use UDP. So this constant or macro that you see here, it's called sock dgram, and dgram stands for datagram. So UDP packets are also called as datagrams. And if you use sock dgram, that means you're telling the socket function call that you want a UDP socket. If you use sock stream, I mean, TCP is a streaming protocol, as you will see in the class later, in the theory classes. That is going to give you a TCP socket, but let's not worry about that at this point of time. And don't worry about this parameter. You can figure out what's going on in that parameter by control clicking into this, and you can figure out what's going on. It says if protocol is 0, 1 is chosen automatically, returns a file descriptor for the new socket, right? So because for the type we have given sock dgram, there could be more than one datagram protocols for those kinds of sockets. But in practicality, we just have just one, UDP, that's all. But if there are more than one datagram protocols later, sometime, then it will just try to choose one of those protocols at random, but we have nothing to worry here because it is definitely going to choose UDP for us, because that's the only datagram protocol that is available on our computers at this point of time. So after you make this call to the socket function, you're going to get a socket file descriptor. As I said before, this is the identification, the ID for the socket. And if this is less than 0, that means some issue happened while you called the socket function. It was not able to create a socket for you, and that's why it returned a negative value. Okay. And so you pray that this succeeds and you have a socket. Okay. So now we need to give this socket an identity, right? So because we are the server here, we have to tell it, okay, open your socket on all of these IP addresses and this is the port, right? So any UDP packet coming in with this number, right? Whatever, this 8080 as the destination port, give it to my process. Which process? When we run this program server.c, it's going to run as a process. And those packets will be delivered because this is how demultiplexing works. Right? We have discussed that in the class before. So what do? We first zero out the contents of the serve address and the client address structures. And what are those structures? Those structures are meant to store the IP address and the port details of these sockets, right? By the way, you might ask, why do we need two of these structures? We will see later what's the need for having this client information, because all we need is some information put into a structure such that that is used to bind the socket to an interface, right, on the server side. So why do we need this client structure? It will become clear to you later. Okay, but we are going to fill these structures with 0, because in the C programming language, when you create a structure, an integer, they are filled up with garbage, right? We don't want them to be all garbled up. We want them to be free of any garbage. So we are going to zero them out. So this memset function does that for you. So what does it do? Since we're going to change memory, that's why we need to give a pointer to that structure. You probably know that if you want a function to change your structure or integer or whatever, you have to give it pass it by reference. So we're giving the address of that. We're telling memset that fill it with zeros, and how much to fill. This is not an integer, right? This is a structure, and the structure can be big, it can be small, but memset does not know what is the size of this structure. So we have to give the size of that structure, that okay, fill zeros for these many bytes. This is the size of the structure. Don't go beyond that, or don't fill less than that. Fill exactly those many zeros. We do that for both the serve address and the client address. Now we're going to fill in the details for the server part. We have just created the socket, but we have not given it any further identity than it being a datagram socket, so UDP socket, but we have not given it an IP address and a port. So what we're doing here is that we're going server address dot family is the IPv4 family. There is nothing to understand here. You just have to remember that. Then, let's take a look at what is there inside this. So just control click on this sock address in structure and you will see what's there inside this. So there is a port, right? It's a 16-bit number, as you can see. It's a unsigned 16-bit type. As you can see, I'm hovering on that. There is a structure inside that called as the internet address structure, right? So if I click in and go inside that, it's nothing but it's a 32-bit number, and we know that IPv4 addresses are 32-bit numbers. So this 32-bit number is actually not present directly in the sock address underscore in structure. There is actually another structure called as in address inside that, and that kind of has that, right? This in address thing inside that. So you have to use two dots, right? If you control click and go inside the structures, it will become very clear to you. So the port is directly present inside the structure, but the IP address is not directly present. It is present inside another structure, and that structure in turn holds the 32-bit value for the IP address, right? And the rest of it is supposed to be just zeros, right? And we have already filled it with zeros, right? Because we have used memset to fill that out with zeros. So what's going on? So we have the family, we have the IP address, and we've used inaddr any. What does this mean? Address to accept any incoming messages, right? So this value is all zeros. So what this tells the operating system is that try to listen on all the interfaces on the computer, localhost, Ethernet, Wi-Fi, howsoever many interfaces are there and whatever might be their IP addresses. We do not want to pick and choose one of them. Open this socket on all of them. And then we fill out the port, and the port happens to be 8080. So you might ask, what is the meaning of this h-tons method, h2ns? So in networks, data usually flows in the big endian format. And in computers, the data is in memory is usually stored in a little endian format. I'll give you a quick example of how that works. So let's just say you have a number, a hexadecimal number, 1234, right? How many bits? 4444, 16-bit number. And you want to store it in memory. So how many bytes of memory do you need? It's a 16-bit number, so you need 2 bytes of memory to store it. And let's just say those memory addresses are address 10 and address 11. So how do we take 1234 and store it at these addresses? What we can do is we can say 12 you go there, 34 you go there. Or what we can do is we can say 34 you go there and 12 you go there. 2 ways in which we can store this number in these 2 addresses. Now, if you just go left to right, the most significant bit, what is 12? Out of this entire number 1234 in hexadecimal, 12 is the most significant byte and 34 is the least significant byte. If the most significant byte 12 goes to the lower memory address of 10 and the least significant byte of 34 goes to the higher memory address of 11, then this is called as the big endian notation. Okay, and networks use it. But what about the other format in which the least significant byte goes to the lower memory address and the most significant byte goes to the higher memory address? And that is little endian. Right? And this is how our computers store data. Okay. So now this port number is a number 8080 and this is coming from the computer. So this is probably in the little endian format, but networks need the data in the big endian format. So we use this conversion. Okay. It says host to network conversion. And since port is a short, right? It's a 16-bit number. Okay. Had it been a 32-bit number, it would have been H2NL. L is for long, S is for short. So that would have looked like this. So H2NL, right? And we could have done that. So this is taking something in the host format, right? The host, the computer, and then converting it into the network format. And this is a short number, 16-bit number. And that's what is going into the port part of the structure. Okay. Similarly, you have functions like N to HS, network to host, short, and N to HL, network to host, long. These functions are also there, and we will see through the duration of the course where they are used. Let me delete these lines for now. So now the serve address structure has all the details, like it's a IPv4 based address, right? And we are binding to any IP, all IP addresses on the computer, and the port information has been given after the requisite conversion. Now we are going to take the socket, we're going to take the server address structure, and we are going to bind the information in the server address structure to the socket. So the socket gets more identity. Until now, all the socket knows that it is a UDP socket. Now we're going to give it IP information and the port information, right? And how do we do that? We call the bind function. We give the identity of the socket and that is what was returned to us by the socket function call. We give the address of the server address structure, and I will come to this cast, in a moment. And then we give the size of the server address thing, and this is how this works, right? This is how this works, because whenever you pass a pointer to a structure, to anything, they don't know how long that structure is going to be. So we give the size of that structure so that they know until what address they should read. Address as in not IP address, the memory address, right? Because a structure can be a variable size. It's not an integer. If it's an int, then maybe okay. Even integers don't have fixed sizes, right? On some systems, they are 2 bytes, on some systems 4 bytes, on some systems they can go up to maybe even 8 bytes. So we are passing the address of a structure to the bind function. That's why we are giving the size of that structure also. That is how it is. If you practice, you will remember this. You don't even have to remember this. I mean, you can keep this code as a reference and keep using it whenever you're creating some socket program. Okay, so now what happens? I mean, this works out fine if the return value of the bind function is not a negative number, then that is successful. But if it is not successful, then we're going to do this. What is this error? Print this error, bind failed, and exit with, look at that, there's an exit value of 1. And we know from our OS lab that if you're not exiting with a value of 0, that means it indicates some kind of a failure, right? So we stop the program right there if bind does not succeed. So now we have a socket. We have given it some kind of an identity. Now let's try to receive something from the client, because we are the server and the client is supposed to send us some message. So the reason why we do this, we take the size of the client address structure, and why the client address structure is going to be used will become clear when you look at this line. What are we doing here? We are trying to receive something from the client. So we run this function here, receive from. This is a blocking function. The server is going to just keep waiting there inside this function until someone sends it some message. If no one sends a message to the server, it will just be stuck on line 44 here. It will not proceed any further. It's a blocking call. And so receive from what? We give the socket information. I mean, this is just how this function call is. I mean, it needs all of this information, as I will show you. Okay. And just practice this as much as possible, and then maybe you will remember this, or you can keep this for as a reference, and you can take a look at this while writing your code, and over time you will learn the different parameters it takes. But I'll tell you why those parameters are being taken by this function. So it needs the socket. Without the socket information, how will the receive from function know from which socket should it be reading information, receiving information? Then what about this buffer? We know this buffer is a character array whose size is max line, which is 1024. So buffer is a character array of 1024 characters. And why do we need that? Because whatever the client sends us, we need to store that somewhere. And we will store that in the buffer here. But just giving buffer, this is the pointer to that array, is not enough. We need to also tell receive from what is the maximum amount of data that can be stored inside this buffer, and that is max line, because that is the size that we used while creating this buffer. So if the client sends more than that, then don't put it in buffer, because it will result in a buffer overflow, and that is always bad. We do not want to write beyond the end boundary of the buffer array, the character array. It can store 1024 elements. Don't go beyond that. We need to tell receive from that. This field here is used for customizing different ways, the behavior of this receive from function at this point of time, and for the scope of this course, you can pass on a 0. This is the flags parameter, And this is used to customize the behavior of the receive from function. If you want to do more research about this, you can go and figure out the different things you can pass here. For the scope of the class and to keep this video short, I'm going to pass a 0, and this works fine for the intent and purpose of what we're trying to do this in this tutorial. Now, this should be enough, right, to receive something from the client. So why are we passing this client address structure and its length? I mean, well, the pointer to the length. Why are we doing that? Why are we passing these things here? Well, this is UDP. We do not know who was going to send us the message. And please mark my words here and pay a lot of attention to what I'm saying, because this is very important for you to know. TCP is a connection-oriented protocol. You know you have a connection. If a client is trying to send you a message, then you know it is coming from this particular client because you have a connection with that client. But in UDP, that's not how things work. You are a server. Anyone can send you a message. Anywhere in the world can send you a message. So if you want to really know the details about the client, because the packet that comes to you will have a source port, it will have a source IP address, all of the information will be there on the packet. So, but how would you be getting it? If you restrict yourself to just these 4 parameters, then sure, you will get the data the client is sending you. But who is the client? If you pass this information, then inside this data structure, the client address data structure, you will have the IP address of the client and you will have the source port number and things like that. And we can use that further, as you will see, to send a message to the client. If the server wants to send a message to the client, well, it needs to know on which port and on what IP address is the client running. Only then the server can send a message back to the client. With just the data that the client is sending you, you won't be able to do that. So it is good to capture that address information. The client address information should be captured by receive from. That's exactly what it is doing. One thing I forgot is that why do we do this cast, right? The struct sock address cast. Because this sock address in, if I just go inside that, this is a structure that is used to describe an internet socket address. Whereas these functions here like bind and receive from, they expect a pointer of type sock addr. That underscore in is not there. And what is this? This is a structure to describe a generic socket address. A generic socket. Sockets can be of different types. They are not always going to be internet sockets. They can be of many different types, right? So receive from, bind, they don't care. They will take a generic socket address pointer. But when we're putting information like the IP address, port information, whatnot, it is convenient for us to use sock addr underscore in. And they are the same size. I think 14 bytes is what they both use. So when we are trying to populate, put the data inside the serve address, client address kind of thing, we create them as type sock addr underscore in, so that you can use this dot syntax to conveniently put the information. But the bind and the receive from and many other function calls that you will see in this laboratory course, they accept the generic type sock addr. So if you just do this cast, the compiler is not going to complain, right? So let's take a look at this receive from again. So we trying to receive something from the client here. The server, has this socket whose ID has been given here. We want the information sent by the client to be put inside this buffer. Max line is the maximum size of buffer. So we're telling receive from not to put any more information inside this. Right? 0 is flags, right? We are not trying to customize the behavior of this function in any way, shape, or form. And we would also want to capture the address information of the client. Who is sending the message? We want to check. Maybe we do not always want to send something back to the client, But maybe if there are two clients trying to communicate and we have blacklisted one client, then maybe we can write a condition here and say, oh, if the client address is such and such, we're going to reject that message. If you are the other one, then we will accept it. You can do whatever you want, but it's UDP. Anyone can send you. There is no connection in UDP. That's why you would want to capture this information. Okay. So as I'll show you in the client program, you're basically sending a string. And what does this receive from function return? I mean, the size of buffer is max line 1024, but is it necessary that the client always is going to send you 1024 characters? No, it might end up sending you less than that. So whatever was actually received from the client, maybe 10 bytes were received. So n is going to be 10. Okay. So we know it's going to be a string because we have written the client program ourselves, as I'll show you in a few seconds here. So what should we do? If buffer has that data, then what is buffer of n? So if n is 10, then 10 bytes have already gotten inside the buffer and they are occupying positions from 0 to 9. So buffer of n is basically buffer of 10, which is the position to the right of the last byte. And if we put a /0, it is going to terminate the string properly. We all know that strings in C need to have this null terminator at the end. Otherwise, if you're printing the string and printf would not know where to end. So we have to terminate the string this way. So we say that, okay, the client sent this %s buffer. Then what do? We then send something to the client. What do? Okay, use this structure, which is, use this socket, which is the socket that the server is going to send a message. It's the same socket that is used for receiving a message. It's the same socket that is used to send a message. So use that socket, send the hello message. We have a hello string here, hello from server. Send that. How much to send? I mean, send to does not know if it's a string or whatever. You're just giving it a pointer and it is going to send these many bytes. How many bytes? What is the length of the string? strlen, hello, just send that much. It looks very similar to this, right? You give a buffer and you give a size because you have to tell receive from, this is the size, don't go beyond that. And here also, this is a pointer. Send whatever is there in this address, but how much to send is basically, this is the length. Don't send beyond that. You might end up sending garbage, right? Or you might end up going beyond your allocated memory range, and then the program is going to crash. You will get a segmentation fault, right? I think many of you have seen that before. There is no need to send any flags, send a 0. There is no need to customize the behavior of send to as far as this course is concerned. And well, whom to send it? The sockfd is the server socket, but to whom to send it? Well, give it this. I mean, you can, maybe not have this const thing there. I mean, you can do that. It is good to have it as const because then no one can, fiddle around with that. But it's your choice. The compiler is not going to complain much, right? Sockaddr, it is a generic socket address. But what we are using here is a sockaddr_in for our convenience. So it's better to just cast it to that, send the address to that, and then the length of that structure. And that is why we had this line of code here. It was the size of the client address structure. And whenever you are sending a structure, as I said before, if you're sending the address to a structure, make sure that you send the length, because then the function that you're passing the pointer to would know, okay, this is the size of that. I'll not go beyond that, right? And that message is going to be sent from the server to the client. And you can say hello message sent and return 0. Let's quickly take a look at the client program here and see what's going on. I mean, the client also is going to use a port, but this is going to be the server port, okay? And the max line thing is for the buffer. And you might ask, why is the client not using a port of its own? Well, the server needs to have a well-known port, because if you're calling yourself a server, then you need to tell everybody, this is my IP, this is the port. That is why it was important to kind of specifically give the server socket a port. The client here does not need to have a well-known port that can tell everybody, oh, this is my port. It is not required. So keep that much in mind, and you will see how this becomes clearer to you when we move through the code here. So yeah, it's a socket which will be created. The client will also have to create its own socket. This buffer is going to store the message coming from the server. Pretty similar to how we used to do it in on the server program. This is what we're gonna send to the server, hello from client. And we just have one sock ADDR in. There we had two. Why? Serve ADDR was used to store the IP address and the port on which the server was going to listen for messages. And the client ADDR structure was used to store the IP address of the client from which the message had come. There's a message from a client, we need to know the IP address and port of the client, and that is why the CLI ADDR structure was used. Here it's just one. Why is that? Let's take a look at that. Okay, so here we create a socket, right? We say, okay, internet IPv4 socket, UDP socket, protocol, choose any one, but there is just one UDP, so that is going to be chosen. If it is a negative thing, exit, say that socket creation failed, but hopefully it will pass. Then we're going to create the memory content just like in the server program, right, of the serve ADDR structure, because that is the only one we have here. And then we're going to put the server information here, right? What is the server information? IPv4 address, host to network, short port, same port on which the server is running. You know, see the server is running on that port here, and that, and then IP ADDR any, right? What does that mean? It's going to work on the same computer here, because you know the server is listening on local host. What is local host? 127.0.0.1. It is an interface that is running on our computer, and anything sent to that is going to be given back to our computer. It is not going to go outside our computer. Since the server is running on all the IP addresses, which also includes localhost, if you do the same thing here, inaddr any, that means our client is going to send it to the localhost thing, and it's going to work. So there is no need to specifically put any IP address of the server, because the IP address, the server is also localhost. It's going to work without you having to give any specific IP address here. The information has been populated here. What do? We send to. You might ask here, Jyoti, wait here. You created a socket on the client side, but where have you given an identity to the socket? Well, you have told it that it's going to be a UDP socket. But what about the IP address and the port on the client side? Well, this information here is for the server side, because the client needs to know, right? I'm sending a message, to whom am I going to send the message? This is the information on the server side for the server. But what about the client socket's identity, the IP identity and the port identity? Well, let me tell you, it is not necessary to do that. On the server side, why was it necessary? Because we wanted the port to be specifically 8080. That is why we did that there. We did that bind process there. On the client side here, it is not necessary, because the moment you do the send to, a random port out of this, whatever is the available port range, right, is going to be chosen for you. It is going to be given to that socket for you. You don't have to bind, because you do not need to know the port number. It can be any random port number. You do not have to be choosing a fixed port number like you did for the server. Okay, that's why binding is not necessary. You can bind, but it is kind of optional here. So you send to what? Use this socket which was created for the client communication. Send this hello message, though it's a pointer. You know, you can cast it, but it is already of that type, so there is no need to cast it here. And how much to send? Well, this is how much you send, right? It's a pointer to the data, but it is not unbounded. There is a limit. Send that much. No need to change the behavior of send to, right? This is where you send. This is the address of the server. Well, the send to function was also used by the server here, right? You might identify the structure. When we were sending a message from the server to the client, we used that. and we had the client address here. And where did we get the client address? In the message that came from the client to the server in this receive from, we captured the client address information, right? And the client was first to talk to the server, right? So this is what is happening here. This is sending a message to the server. The server address is right here, and then the size of server address, because it's a pointer to a structure and you need to give the size of that structure, and that is what we have done here. And we said, okay, hello message sent. Then when the server is going to send a message, right? Here, we'll be here in this method, waiting for the server to send something. Okay, receive the message from the same socket that's been created for the client. Use this buffer to receive the message from the server. This is the maximum size of the buffer. Don't take more than 1024 bytes. No need to customize the behavior of the socket. Just the basic thing is fine. And well, capture the server information again. We already know that. We already have filled that information, but just for fun, right? Because this function takes these parameters, might as well just give it those parameters. And the message comes from the server, and then we'll capture the IP address and the port information of the server. We already know that, but it's a message coming through UDP, might as well capture it. The server did the same thing. When it received something from the client, it captured the client address here, right? Now it's the client's turn to store the server IP and the host information in the same structure. Why there is no need to create another one? So you get something in the buffer, and let's just say this n is like 20. That means 20 bytes were received. So in the buffer array 0 to 19 are those bytes. So buffer of 20 is going to be, should be the null terminator. Otherwise, you'll not be able to print it properly. In the next line, we are printing whatever has come from the server. Then we close the sockets. It's important to close the sockets. Don't leave the sockets hanging, because it will just keep resources busy on the operating system. Okay. And here also I should close the socket. Okay. All right. So I'll save both these files and let's try to run them. Right. So if you click on this button here, okay. So if you just go to terminal and say new terminal, you will get a terminal right inside your WSL, right? So I am in this directory. I'll go to CNLab. I'll go to UDP. I'm going to do GCC, and always use the -o flag. Don't run GCC with just the name of the C file, because the output is going to be a.out, and there are two programs here. The first one, the output will go to a.out. The second one, when you do that, then it's going to override the previous one. So just use the -o, the output name, right? Let's call it server, and compile the server.c file. Many of you just do gcc server.c. Why? Just give it the name. This is going to be the name of the executable which this compiler is going to create. Okay, got created. I'll just say split the terminal bash. Okay, we have it, the terminal here. We are in the correct directory. So I'll say gcc -o client.c. There you go. Both the programs have been compiled. I'll start the server first, because it needs to be waiting for the client to send it something. So start the server first. I'll say /server, enter. Where is it blocked? It is blocked on this line. Okay, because the server, sorry, the socket got created. We did not see socket creation failed. The binding did not fail because we did not see that. So it's basically blocked. It's waiting for the client to send it something. So we will run the client here, and you see it says hello message sent. And here in the server, you can see client, hello from client. Then here the server sends a message and the client gets it, hello from server. Then both of them exit. So try to study these programs in more details, and over time you will learn this properly. Thank you.